Let's find the variance and standard deviation of a probability distribution. So this is a generalization of the standard deviation equation and variance that we gave ourselves before. So a small note about this, when you have data that is uniformly distributed, so x1 occurs once, x2 occurs once, x3, and maybe they're the same thing, maybe x1 is equal to x2, but they both occur once in your data set, then you can find the standard deviation of the set by taking every point, subtracting the average, squaring, divided by n minus 1. Right? That's how you find the variance. But if you have data that you don't care about equally, maybe the data occurs with different probabilities, then we have a generalization. The variance will be, again, the sum of squared values, and the values will be x minus the average, or sometimes we call that expected value. They're the same thing. Expected value of a probability distribution is the average of that probability distribution. But because we care about the data differently, we weight this difference with the probability of that x value occurring. So you can see the similarities here. It's going to give us the same measure, a squared distance away from the center, but now we just care about our data differently. So we use a weighted average. Let's go through this. So our first question, we flip a fair coin twice and we count the number of heads and obtain the following probability distribution. So because we just recently introduced probability distributions, I won't spend a lot of time going through this, but I think if you're flipping twice and you're counting the number of heads, the way to get 0 heads is a tail and a tail. So you get 1/2 times 1/2, that's 1/4. The way you can get 1 head, there's 2 different ways to do that. You can get a head and then a tail, or a tail and then a head. Now, this seems kind of silly because heads and tails are equal in their probabilities, right? It's a fair coin. But either way, you get 1/4. And either of these would satisfy the condition of having 1 head. So 1/4 plus 1/4 gives you 1/2. And let's finish with the number of ways to get 2 heads. It's got to be there and there. So 1/2 times another 1/2. That's 1/4. So we have that probability. Okay, so the probability distribution is correct. You don't have to go through with that if you already have the probability distribution, because let's remind ourselves of that expected value equation again. This part here asks us for the expected value. The expected value, or the average, is the sum of the events multiplied by the probabilities, and that's exactly what this table gives me. I'm finding the expected value for the number of heads. So the first event that could happen is I could have 0 heads. The probability of 0 is 1/4. All right, so we should be good at finding expected value at this point. When you go through this, you get an expected value of 1, which kind of makes sense if you think about it. You're flipping a fair coin twice. You would expect one of them to be heads, right? And maybe the other one tails. Let's work on the second part. The variance for the number of heads present in 2 flips. The variance is the sum of the events minus the expected value, or the average, squared, so we don't get that cancellation, and weighted by their probabilities. So let's actually go through this. The first term in the sum, the first x value is 0. I'm expecting 1. I square that, and then the probability of 0 is 0.25. The next term in the sum, x could be 1. I'm expecting 1. I square that distance, and I multiply by the probability of having 1 head, 0.5. The final term in the sum the last possibility for the number of heads. You could have 2 heads, you're expecting 1, you square it, you multiply by the probability of having 2 heads. So let's actually go through this. Here you get -1, but then when you square -1, you get a 1. So this term just becomes 0.25. Here, 1 minus 1 is 0. 0 squared is 0. 0 times 0.5 is 0. Here, 2 minus 1 is 1. 1 squared is 1. 1 times 0.25. So we have 0.25 plus 0.25. That's 0.5. So this is your variance. So the units here, number of heads squared. All right, now to find the standard deviation, remind yourself the standard deviation is the square root of the variance. So you've done all the hard work. What is the square root of the variance? You get about 0.707.